scary headlines across the globe. A 70% more transmissible virus due to a mutation in the UK. Borders are shut down. The Christmas is canceled. Here's how you can actually science this up in a way that you can actually understand what's going on and understand that there's actually no need to panic here, but there is need to be very vigilant and understand what mutations are, how they affect coronavirus. Do they affect the vaccine and its efficacy? Does it make the virus more deadly, more reproducible, or what? And so let's talk about that. Dr. Z, welcome to the Z-Dog MD show. All right, here's the thing. Headlines all around right now saying out of control, new mutation in the UK. UK itself goes on lockdown, London in particular, nearby European countries shutting their borders to Great Britain, panic, headlines, everything the usual. All right, let's just go through the science of what's actually happening. First of all, what is a mutation in a virus? What you're talking about is the RNA, the genetic code of the virus. It uses RNA, right? Humans use DNA as their primary genetic code. A mutation is simply a change. That's what it means, a change in the code. And that makes you think change relative to what? So what are you comparing it to? And typically in this case, we're comparing it to the original Wuhan strain of the virus that was, reported back in December or whenever, although it may have pre-existed that. And so what we've noticed from the very beginning of this outbreak is that this virus has the capacity to undergo mutation, like many RNA viruses. So influenza is a good example. Influenza can mutate very easily. And it turns out RNA viruses don't have as aggressive of error correction software. They don't have the machinery to correct errors as well as, say, human DNA does. We have great machinery that proofreads and corrects our DNA, so there's much less likely you're going to have mutation. But with RNA viruses, because there are so many copies being generated in the cells of this genetic information, and it has poor, proofreading, you end up introducing mutations, changes in the code. Now, some of these mutations make it impossible for the virus to even form properly, and they just go away. You don't even see them out in the wild because they never make it. Some of them have no effect on the virus one way or the other. And they're just another statistical change in the virus, and whether they show up in mass when you start testing or not is a matter a little bit of luck. Do enough people get this particular strain and spread it through super spreader events, a large church or a big gathering or something that we've talked about on the show before. And then some mutations actually confer an advantage on the virus relative to its its baseline peers. And what that means is maybe it is easily transmitted compared to its other ones. And with this particular mutation, we're going to talk about that. So something in the changed genetic code changes the protein structure of the virus and allows it to better infect human cells or to spread it via a different mechanism or to replicate more efficiently. There's a bunch of different ways this can happen. So that then makes the virus more easy to catch and to spread compared to its peer viruses that are not having this mutation. Now, other mutations may actually make the virus more deadly. So in other words, when they do spread, they are more likely to kill you or cause severe disease. And some mutations make it less deadly. And often it's a mix of things. So an increase in contagiousness of the virus or the reproductive number, in other words, how many people it infects, one individual infects on average, if that goes up, sometimes the fatality or severe illness factor of the virus goes down. And it's a mix, because remember, if a virus kills you really quickly and right away, it's not going to spread as easily. Ebola is a good example of this, right? So this one is somewhere in between, so it's been able to spread. So this is kind of what mutations can do, and they arise, again, from the replication of the virus. It's not a conscious thing the virus does. The virus doesn't have a brain. There's no intelligent design here. It's simple numbers. You have a whole population of viruses out in the world replicating, and there's a bunch of mutations that can arise. Now, what would make a mutation then become more dominant in a population? In other words, when you're talking about the British mutation, people are saying, I'm just pulling up your comments here, people are saying It's now becoming the dominant mutation. It was first discovered in September, or characterized in September in Great Britain, and now it's like the majority of cases in London. And so what would then allow a mutation to do that? Well, it turns out if there's several ways that this could happen. It could be that the mutation made it more transmissible, in which case it's more likely to spread, so it's more likely to become the dominant viral mutation. Or, like I said, these mutations are out there, and it just so happens by luck of a super spreader event or 2 or 3, this particular virus got a kind of a handhold and now becomes the dominant virus. Now, those are totally different scenarios, because one is just dumb luck and it's not going to change really the dynamics of the pandemic. And the other says, oh no, if this thing is more spreadable, it's going to change the dynamics of the pandemic. So this is how you have to think about mutation from a purely scientific standpoint, if you're going to understand then what the news reports are saying about this specific mutation. Now, to back up a second, from the beginning of this thing, we've seen mutations change. So the original Wuhan strain is not the one that became dominant after it spread to Europe. There was a separate set of mutations that then became the dominant strain after the European exodus of this virus. And so we see this kind of drift in the patterns of mutations. Now, again, these mutations may do nothing different in terms of transmissibility, but you can just follow them by sequencing the code. Now, remember, Iceland scienced the crap out of this early on. They sequence every single person that tests positive in their island. So they have a good genetic, anybody could do that. We just haven't yet. So if you sequence everything, then you can follow its genetic fingerprint and actually see where it's going around the world. So back to this. The British UK mutation that they're talking about, it's not one mutation. It's actually 17 to 20 mutations. And remember, you can have a bunch of mutations that kind of ride along with this particular virus. So you know, oh, this is this particular strain because it has this pattern of changes. But it turns out of all of those, there are 2 that actually affect the business, what's felt to be the business end of this virus, the spike protein that allows it to bind to human cells and enter. Now, one of those mutations is a change to the protein that may make it more likely to, it's in the receptor affinity site. So in other words, it might make it more likely to bind to human cells and enter, which could change the dynamics, right? Make it more infective, easier to spread, easier to enter cells and reproduce and get a head start. So that's one mutation out of the 17. The second is a deletion mutation. So a tiny piece of that spike protein is gone. The code that tells the protein how it's made, those few amino acids are gone. And what that seems to do is make that spike protein a little more resistant to the antibodies that form against the spike protein in natural infection. So, and the way they figured that out is there was a patient that was resistant to convalescent plasma, which contains a mix of antibodies made during natural infection to the virus. So this, I think, triggered concern in the British scientific group that was looking at this, and then ultimately in the British government. They said, you know what? Here's what we know. We know that this thing now has become a dominant mutation in London and its surrounding areas. We know that it has these particular mutations. Our modeling data, mathematical modeling data, says that it might be 70% more transmissible in terms of reproductive number, R naught transmissibility, than the standard wild-type virus, unmutated virus. But we can't say for sure that that's true, because to do that, you'd have to actually go into the lab, infect animals, do these studies to say, oh, is it actually more transmissible? Or are our models just saying one thing, but in reality what happened is it was just luck that this mutation was selected for through a series of human behaviors. In other words, people who had the original mutation were more likely to do dumb things like gather in huge groups, not wear a mask, not wash their hands, not distance, ride on, be in crowded events, super spreader events, or it was just the dumb luck of there was a super spreader, a hyper emitter, someone who just by talking spreads this thing more than an average person, and we still don't understand why that is. And that led to this being the dominant strain. So they don't know yet, but they're concerned enough that, well, if it's possible that it spreads more easily, well, that's a big deal. because it's going to make it much more likely that more people get infected easier, which is going to make the pandemic harder to contain and is going to be more likely to continue to overwhelm hospitals. That's the main concern that they have, I think, right now. And that's why they're taking this pretty aggressive precaution and why the news is trumpeting the 70% number and all that, which I think is a little misleading. It's really, okay, that's one model, right? We know how models work in this pandemic, but it is okay to have an abundance of caution. The problem is, of course, what they're doing has huge economic, social consequences. So we have to be very careful when we look at this science, right? So the other question then that arises, and now, by the way, this is important. Some of these mutations have arisen independently in other countries, South Africa. So in South Africa, these two same mutations I was talking about were seen there independently, we presume, because you can actually kind of use genetic fingerprinting to track, because we've seen these mutations arise in other places, but it looks like it was from British source. But these mutations may have independently arisen. Remember those minks? Those little furry, cute things that make the mink coats that evil people apparently wear and get blood splashed on them by PETA. Those minks, that one of those mutations was seen in that population. In South Africa, we have both mutations. So what does this tell you? It tells you these can arise independently. If they become dominant, it tells you that they might confer a reproductive advantage on this virus because they're being selected for independently. Like, they're likely to occur statistically whenever the virus is reproducing, but the environmental conditions are selecting these viruses for some reason. They have an advantage. So that makes you concerned. Well, okay, this thing is a little more slick than your wild type, unmutated, Wuhan, old school coronavirus. So that's why I think they're concerned. Now, this brings up a question. Now, what about the vaccine? So if we can mutate functionality in the spike protein, as you guys know, if you've watched any of our other videos, the new mRNA, Pfizer and Moderna vaccines, which are 94 and 95% effective against whatever is circulating on average in the United States and elsewhere in the trials that have been done, could it be that now this spike protein is going to change enough that it's going to evade the vaccine? That's called immunological escape or vaccine escape. Now, there's precedent for this. For example, HIV, which is an RNA vaccine, RNA virus, mutates a lot and can actually develop resistance to the drugs we use to treat it and make it very hard to make a vaccine. It turns out influenza, as we know, you get a different flu shot every year. Why? Because influenza over time, historically, has mutated quite a bit and can evade, because it changes its surface protein configuration, can evade a single vaccine. So you have to keep changing it in the current formulation of vaccines. But what they are not telling you, or what you may not know, is that this doesn't happen overnight. There isn't an on-off switch that makes a virus like the coronavirus suddenly able to evade our new vaccines. And this is why. It's often going to take a series of mutations over time spreading in order for a virus to evade or to develop enough changes in its spike protein that the overwhelming immune response that these new vaccines generate to the spike can be evaded. And the reason is these vaccines produce, through their mRNA instructions, a very purified spike protein that the body and an adjuvant immune response, all those fevers and muscle aches and headaches and arm pain, that's the innate immune system revving up in response to the vaccine. It generates this massive response to the spike protein on multiple fronts on the spike. So these so-called neutralizing antibodies can knock out the spike through just this mass attack. It takes quite a bit of change in that virus to evade that. Now, what the data seems to show so far is that takes somewhere in the 5-year range, say for a standard cold coronavirus, or for influenza, it takes years. The reason every year we have influenza vaccine change is not because it's mutating every year, but because there's already a population of influenza that has degenerated over, decades, millennia, that just changes which is the dominant strain every year. And so you have to try to predict which one it is. But every now and again, there'll be a new strain that humans haven't seen. And that is rare for a reason, because it takes time and it has to be selected for as having some advantage when it replicates. So with this coronavirus, there really isn't an immediate danger that this thing's going to evade our new vaccines. Now, that doesn't mean that it can't happen. It doesn't mean that we shouldn't be super vigilant. And why is that? Because one of the selection pressures, in other words, one of the things that will sort of start to pick one mutation over another, is a population that becomes progressively more resistant to the circulating strain that already exists. So as we start to infect more humans, there's going to generate a herd immunity. As we vaccinate humans, there's going to generate more and more herd immunity, meaning more people are resistant, which means now the virus that's left can only really thrive if we select for mutations that start to evade some of those defenses. But that takes a lot of time. It's more likely to happen. This is very important. It's more likely to happen when you have unmitigated viral replication that can allow a big pool of mutants to select from. How do you avoid that? It's really quite simple. Don't let the thing replicate. So how do you avoid that? Vaccinate anyone who will be vaccinated, so you create rapid immunity that overwhelms the viral capacity to reproduce and select for mutants. Physical distancing, masking, washing your hands, avoiding large gatherings in the short run to suppress that viral replication are not numbered down, so that you're not generating a ton of virus that can potentially have a mutation that then has an advantage. It is crucially important that we vaccinate the population as much as we can and as quickly as we can, and that we continue with the things that we've all been saying to do the whole time. And that is the crucial piece of this. Otherwise, what may happen is you have enough replication out there that you will eventually evade vaccine. Now, it's possible you're going to evade vaccine anyways, but it may take years, in which case, here's the great thing about these new mRNA vaccines. Unlike influenza and other previous vaccines, you have to grow them in a culture, you have to do a lot of drama with the virus, inactivate it, do this and that, in order to change its protectivity against new strains. With the new mRNA vaccines, it's a plug and play change. Oh, the virus changed its genetic code. We have it right here. Plug and play. New mRNA, new spike protein with the mutations, new vaccine, right? You still have to test it. You still have to make sure it's safe. But you can do that relatively quickly. So this is really incredibly good news, not just for coronavirus, but for future vaccines against future pandemics and diseases we already have. Now, again, you can compare. Influenza mutates rapidly. Measles, which is also an RNA virus, does not. The same measles vaccine that worked in the 50s has 99% efficacy after 2 doses today. So when you read these headlines, don't panic, but do think about this scientifically. Do get the vaccine when it comes out for you. Don't cut in line. We did a show on this, right? Do the current things we're talking about. Distance, avoid large gatherings, wear a mask, wash your hands, and that's not going to be forever. I don't care what the conspiracy people are saying. It's not some kind of government control, though it feels like it. It sure does, doesn't it, sometimes, to us with libertarian sensibilities? But I'm telling you, the science has beaten my libertarian sensibilities on this, all right? And then the other thing to remember is we better develop really good testing and genotyping in the US and beyond so that we can watch, because this is what we ought to do. If you have a vaccinated individual who gets sick anyways, you better genotype that strain, because it could be an early example of a variant that has evaded the vaccine. And then you know about it. So either you get a head start changing the vaccine for the next cycle, or you're going to do this anyways. As we see infections drop to a level, we can do proper contact tracing, proper testing, proper individual quarantine instead of this BS of locking down entire societies, which is like a dumb bomb that has so much collateral damage. Use a smart bomb and just get like what the Koreans did. Just get the people who are sick and be very aggressive about it and monitor for new mutations. That's what we have to do, instead of having to shut down right before Christmas in a panic because we don't fricking get it right in the first place. Got it? So that's the deal. Let's look at some comments here. And thanks to everyone on Facebook who's been sending stars. We're streaming live on Facebook. This will go up to Locals. If you haven't downloaded the Locals app and followed me there, you're missing out on social media done right, without the trolls and the nonsense and the ads and all that. It's just way better there. And then YouTube, it'll go up on YouTube as well. Let's see. Sell that fear, David Bowman. You know, I don't know whether you're a conspiracy buff or not, but yeah, fear does sell. And that's why the headlines are doing this. That's why I want to do the show, so that you guys can actually be informed and not afraid. This is not something to panic about. It's something to go, oh, okay. Yeah, this makes sense. This is what the virus would do. Let's do something about it, right? Instead of freaking out. Let's see. Don't cut in line. You mean like Pelosi and Schumer, Dennis Jacks, or Pence? So this is not a politically divided thing. Romney, Pence, Schumer, Pelosi, they all got the vaccine. And they'll justify it by saying we need continuity of government and we need to set an example. That's all fine. You make your own decision whether you think it's better that they get it or people on the front lines and nursing home people who are at the highest risk, who are 40 to 45% of our fatalities during this pandemic. If you're talking about targeted interventions, that's where you target the interventions. I say let the politicians get COVID so they see what it's like. But don't quote me on that, except that this is live and I just said it. All they know here is lockdown and more lockdown. Adam Makich, I wonder if you're in the UK. Well, that's the problem. They're using these blunt instruments because they have a failure of the original science of doing what they... Do you think the Koreans locked down? No. They actually scienced the crap out of it early on. Now, they did some invasive stuff to people's privacy. If you're not willing to tolerate that, then you're going to have to put up with this insanity, right? So there's trade-offs in everything. There really is. There's no one answer for this. There's a bunch of answers, and a society has to decide how it wants to play it. Those with autoimmune diseases, should we get it? Jennifer Limon. Okay, so I'm going to do a separate show on this, but here's the punchline to that. Nobody knows the answer to autoimmune disease patients and these new coronavirus vaccines because it hasn't been studied in autoimmune patients specifically. However, there is no good reason from first principles on the mRNA vaccine to say you shouldn't get it. And the reason is it's not a live virus, so it doesn't replicate, so autoimmunity shouldn't be a problem for you because you're not going to be at higher risk of getting unmitigated viral replication from a live attenuated virus. And if anything, autoimmune patients would be at higher risk of being sick from COVID and dying. So there's more reason that the risk-benefit ratio favors get the vaccine. Now, with pregnancy, it's a similar thing. We haven't studied it in pregnancy, which is too bad yet, but there's no reason. And in fact, the American College of Obstetricians and Gynecologists and the Society for Maternal Fetal Medicine all say it's probably a good idea for pregnant women to get this vaccine because on balance, there's no reason to imagine that it is going to be harmful in pregnancy. But again, it'd be nice to study it. Right? So you have to make your own determination. And same in breastfeeding. Antibodies do cross into breast milk. They cross the placenta. That's why we recommend influenza vaccine in pregnant women, because it's a killed virus. You generate antibodies. It crosses to your child. It protects your child in the first 6 months of life while those antibodies are present and during breastfeeding, which is tremendous. Why don't we give MMR to mothers? Because there's a live attenuated virus there, and you worry that it can replicate in people that have some immune compromise and in pregnant women. So we don't give live attenuated virus to pregnant women. We give it right after they've delivered. So that's something to think about for another show. In any case, I want you to share this. If you haven't become a supporter yet, you're missing out on a lot of real intelligent discussion instead of what is probably 30% of the comments here, which make me want to stab my eyes out. And then the rest of the comments are really fantastic. Yeah, they really are. Actually, I'm looking at some of these, and these are great. So that's easy. Go to zdogmd.com/supporters, and it's all explained, all the different links on how to do that. I love you guys so much. Again, let's come together. It's the holidays. Let's stop panicking. Let's not let the mainstream media freak us out too, because that bothers me a lot when I see these headlines and then I get a million messages. People are understandably scared. They understandably don't distrust. They distrust government. They distrust us physicians. They distrust mainstream media, but yet they're still manipulated by the algorithms and all of this. So let's get beyond that and come together and understand this rationally so we can make good decisions. All right, guys, I love you, and we are out. Peace.